Okay, so I'll be doing 11i. If f of x is differentiable at a, then f of x is continuous at a. So let's start by writing our two definitions down. So we are given that is differentiable. So let's use the definition of differentiable and say f prime of x is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So that's what differentiable means. We are trying to prove that it's continuous, so let's put want to state. For it to be continuous, the limit as x approaches a of f of x must equal f of a. We can also rewrite this by subtracting the f of a to this side. So let's write the limit as x approaches a of f of x minus f of a is equal to 0. So if we prove that this side is equal to 0, that solves the proof. So let's start by rewriting this part. So it's the limit as x approaches a of f of x. The limit only is for this f of x first, minus f of a. And we can use the limit property of subtraction here to combine the two, since the f of a is right there. So from here, what we're going to do is multiply this by 1. So we are going to multiply this by x minus a over x minus a. So we can use the limit property of multiplication here to get f of x minus f of a over x minus a times the limit as x approaches a of x minus a. So what we have here is, this is the definition of a derivative, so we can substitute this for f prime of x. And this, you just plug in a wherever you see x, so it's a minus a, which we know is 0, so it's f prime of x times 0, and anything times 0 is 0. So since this is 0, we know that this is true, and we can prove this to be continuous.